The next thing that I want students to be able to tell me is the degree of a polynomial. Now you do that by adding the exponents on any unknowns in each term. That gives you the degree of each term. So we've got 7, 13, 15, and then the highest of these gives you the degree of the whole polynomial, 15 in this example. So if I break this down into atoms, I get this. My first atom is, I'm using the word degree here. I want them to know what degree means. And I obviously would do some work to make sure that they don't conflate it with degree as in angle measurement. I then need them to be able to identify the degree of any individual term, to then identify the degree of the whole polynomial, and then based on that to give the name of the polynomial. So I think atoms 2, 3, 4 are transformations and categoricals, which I'll get into in a bit. But first of all, know what degree means. So I'm proposing I give them a fact about the concept degree, because I don't want to get into a big rabbit hole about the concept itself. I only really want them to be able to identify degree so that they can then give the name based on the degree. So I am introducing a new concept. I just want them to be able to make some kind of meaning of it. I don't necessarily at this stage want a full conceptualization of degree, but I want enough that they don't feel overly stressed out using this word, which is completely meaningless. This is going to be a little challenging because I think degree is actually best understood as something called a fact system. So many facts come together to explain what we mean by the degree of a polynomial. For example, tells us how many roots there can be, tells us how complex and changing the shape of its geometric representation can be. In short, it tells us something about how complex the polynomial might be. So that's all quite far beyond what I want to get to at this level. Far too many additional concepts there. It'll take us down a rabbit hole. I just want students to be able to identify the degree and then name the polynomial based on that degree. So I'm going to have to draw a limit somewhere. And I'm prepared to go down one level and just offer this fairly simple fact. The degree of a polynomial tells us about how complex the polynomial can be. Now, this has its problems. Facts connect concepts, and if the concepts are all known and understood already, then the fact will be understood. But in this case, they can identify polynomials now. Well, they don't have a conceptualization of degree because I've not conveyed that, but also this one. I mean, this seems reasonable. It tells us about how complex the polynomial can be, but what does complex mean in this context? And this is a mistake that I think can quite frequently be made. This is an English word. It is a reasonably well-known, well-understood English word. This sentence is comprised of words, most of which will be familiar in some way, can be said, can be understood in one context, but in this context, what does complex mean? So really this is not giving away very much in terms of what degree is and what degree really means. But to go further down this, I think it's a risky diversion at this point, given my learning intentions. So I could have come back and start exploring all of this stuff with respect to degree at a later point. We could, especially when we start looking at the graphs and start solving equations, I could explain that a more complex polynomial has potentially more roots. Higher degree polynomials have potentially more roots. But I'm just going to kind of lean a little bit on trust for now. So what I might say here is something like, now I'm going to show you how to identify the degree of a polynomial. I cannot explain today exactly what degree means or everything it tells us. I can tell you that the degree of a polynomial tells us something about how complex a polynomial might be. The higher the degree, the more complex it might be. So that's a fact, and I'll keep reminding you of that fact. But you probably feel unsure what I mean by complex, and that's normal. I haven't explained really what that means yet, but I am going to in the future. Now, this isn't really ideal. There's probably a better design that avoids the need for this, but I also believe it's fine. The concepts in mathematics are connected in this sort of really complex, multi-dimensional way. I don't really know how to sketch out and draw things that are multi-dimensional. Picture a tesseract, something in 4D space. They are stitched together in very complex ways, and it's impossible. I think it's borderline impossible to unravel all of that complex interconnectedness into a simple linear form. And yet we have to communicate them across this single linear dimension of time. So sometimes I find these kinds of imperfections, these wrinkles, do emerge, but I also think that they're manageable. There's then this other design choice, just to draw a line under this. There's another design choice that I'm making. I'm going partway down this rabbit hole because I want my students to be comfortable with complicated looking expressions like this one, so that when we come back to expressions like this one instead, I want this to seem relatively straightforward, relatively simple by comparison. And then expressions like these and one more. I want expressions like these to suddenly feel trivial, super simple. I also do like the approach of starting with something like this because it fully generalizes rather than only introducing the special case of univariate polynomials, so polynomials with only one unknown. But it's okay to make a different design choice, one that will probably simplify the early communication. If you stick to just univariate polynomials like these, then you don't have to include a whole atom on working out the degree of each term. You can instead just talk about searching for the highest exponent on any unknown in the expression. So that is an equally legitimate design choice, but I have my reasons for wanting to start with expressions like these, to take it a little further, to give a more generalized understanding of everything, so that coming to these cases again here, the ones they're most likely to encounter in the exam, these just feel, as I say, really trivial, really simple by the end of it.